So that's it. So today, I'd like for you to take notes because some of this stuff is gonna like come down really fast. Today, bref, we're just doing definitions, and I hate it, but it's life. Just so that we're all on the same page. A lot of you have seen like this idea of graph theory before, um, especially if you were in like grade 10, like higher up math. You've seen it. Um, so it shouldn't be too difficult. If anything, like I swear to God, I'm not gonna be exaggerating or anything, but this is like the easiest unit because it's highly visual. Okay, so if you're not good with like adding, subtracting, algebra, like I got something for you. Okay, this is like the least math of the mathy things, and for a lot of you, it's gonna click really quickly, and that's good. The hardest part though is going to be able to remember which definition's which. Okay. Sounds good? I have a new purple pen because today's a good day, and so graph theory. That is terrible. Oh my god. I should get lined paper, but I don't have it. Okay. So the first thing to remember when we talk about graph theory is that who here knows what a graph is? Like a Cartesian plane. We've all seen that before, x and y. Okay, we're not talking about that. Okay? So that idea of a graph can leave your mind, and instead we're focusing on more like picture-based things. Okay? So graphs in this type of unit are going to look something like this. And don't, right, they're using the word graph, thank you. They're using the word graph here just um, to explain a different branch of math, okay? So in reality, you will never see any of this again unless you go all the way through CEGEP and into like higher university level courses. So like year 3 university is when you would see this if you're studying in like pure and applied mathematics. So will this ever come back to you? No. But, right, it's a stepping stone to leaving this place. I know you guys love me so much, but at the end of the day, it's like, you want to move on, right?
Yes.
That's what I think. At least I'm honest, right? At least I say you're not going to use this in your everyday life. This is very common in like engineering. So if you want to become like an engineer one day, things like electrical and mechanical, graph theory is used. But besides that and math, yeah, not really. So two simple definitions. So the first one is a vertice. So a vertex, or like in plural is vertice. Vertice. Okay. And then this here is a point. Okay.
Period.
So it's the same thing. A vertex is one, vertices is like numerous, right? It's like sheep, sheeps, goose, geese, things like that. And this is a point, okay? So a vertex is A, B, or C, right? So how many vertices do I have in this graph? 3. Okay, you already passed like this today's course, okay? Like, I'm gonna try to make it as simple as possible. There's no need to exaggerate it, okay? The next point that you need, the next definition you need to know is an edge. So if a vertex was a point, what do you think the edge will be? So the line, so a line that connects two vertices. Isn't this so much fun? Don't you guys get excited when you look at your schedule and you have this class first? I know you do. You don't have to lie.
Sure.
Also, I don't know if you care about my life, but you've heard about a lot of like universities being shut down because our classes, like my classes, like in first year I had classes of like 600, 700, 800 people in like one room. So a lot of schools, like especially like New York State and stuff, have been like shutting down their schools. And anyways, McGill is currently considering alternative options. Was the email I received. But then after, it's like it's the idea, right, that I work here, right? So it's like it's almost like I went to Italy with all these people and I'm bringing them to McGill,
Pretty much.
right? And all those people have families. So that's why viruses are dangerous. But you know, I took whole courses and stuff on like virology in university, and I really loved it. But when it like comes down to like real life, it kind of sucks. You know, that's what I think. Okay, so does that make sense? So a vertex here, for example, could be vertex A. That's how you would write it. You just write A. Here, an edge, as an example, could be, for example, BC. Okay? So BC, you write the two letters together, and that indicates that it's an edge, okay, that they're connected. So I'm talking about this line from B to C. Okay? Does that make sense, or are we lost already? Please don't get lost, okay? If you have been doing like really poorly this entire like year, this is your chance to like pull your grade up for term 3, so I can give you as many points as possible, so that if you like flunk the final, like maybe we'll still be able to do something, right? That's kind of where I'm headed, and that's why this is left last. Okay? We'll see. Everything's possible.
Great.
Sir, why is B, sir?
What? So this here, okay, is what it's also an edge. So this edge starts at B and ends at B. Okay? So this would be called BB, which I think is funny. It's like baby. BB. I think it's funny. I don't know. Maybe you guys think it's funny, maybe you don't. But that basically starts at one vertex and ends at the same vertex. Okay? Is that good? We're going to take as much time as we need to digest this, and especially since it's early, like, we'll take probably more time than we should, but we have all week to do this, and I think I can do it in one day. So here, the next is the order of the graph. So the order of the graph is the number of vertices. Okay? Number of vertices. So what's the order of this graph? How many vertices do I have? 3. So the order is equal to 3. Easy as that. Okay. Are we okay with this, how I found this, the order of the graph? Yeah? So let's say I add a point here, okay, and I add point D. Is my order still the same? If I add a point here, point D, is my order the same or does it change? It changes, right? Because now in one graph, I'm going to have 4 different vertices, okay? So the, pardon? No, so here, right, in one picture, it's going to be clear. It's not like there's going to be a hidden coordinate like somewhere at the bottom of like the page, right? It's going to be like within a box. And you'll see here, let's say within my box, I have A, B, C, and D. So I have 4 vertices, so my order is 4. Okay? So even if they're not connected, the vertices still count. Sounds good? And next we have the degree of a vertex. So what was vertex? So a vertex is a point, right? So the degree of a point or the degree of a vertex is how many lines leave or come to the vertex. Okay? So we'll say how or maybe here we can say the number of lines connected to a vertex. So then here what we're going to do it for A, we're going to do it for B, we're going to do it for C, and we're going to do it for D. Okay? So how many lines connect to A? So what is the degree of vertex A? Good morning. Thank you. So what's the degree of vertex A? So what are the number of lines that connect to point A? So 1. There's one line that goes into A, right? We're going to skip B, and let's do C. So what's the order of vertex C? So it's also 1. What's the order of vertex D? 0. Okay. And who wants to take a guess at the order of vertex B? This is your most challenging question. Yeah. Close. It's not 2. It's not 3 either. So it's 4, okay? And what you need to do is basically, have you ever taken a screenshot of something? Yeah. So how my brain works when it comes to this is that I take a screenshot of the point, okay? So I go like this, right? You know what I mean? Like you take a smaller screenshot of something. So within this box, I count the amount of lines that are leaving the point, right? So here I have 1 point going down, 1 point going left, 1 point going up, and 1 point going right. So even if it's the same edge, right, it counts as 2 degrees if it comes back, okay? So here I have 1, 2, 3, and 4, okay? Because there are 4 lines leaving from my small screenshot of the vertex. You've given up? So let's say, right, if it was like this. I just want to make sure that this is clear. If it was A, B, and C, okay, like this one down here, example 2, let's say, what would be the order of B, or the degree of B? How many lines connect to B? 2, right? So the difference between this one, let's say if I draw a line out like this, oops, what would be my degree of the vertex here? So 3, and right, so if I connect this back to here, then after my degree becomes 4, okay? Because I have yet another intersection. What? How this one is 4? Because here, let's look at B. I'm going to move my paper down. So let's look at vertex B, right? So I have this point here, this line here. I have this line that goes like this, and this line that goes like this, right? So it doesn't matter if they're connected or not. It's how many are leaving, right? How many are leaving? So here it's like a street intersection, right? So it stops at B, right? So here, like the edge from like A to B stops. But this one here, oh, I understand what you're saying. This loop here, right, is continuing. It's like one road, okay? But this is almost like when you're driving and you come to like a 4-corner stop, right? If I have 2 streets that are like this, okay, here you would say, what's the degree of this street? You would say 4, right? Because they're connected like that. But you don't know long term if this road is going around like this and connecting back to this street, right? Because when you're at the intersection, you can't see that far. So you don't really care. You care about the intersection where all the cars are meeting up, okay? So it can be like this one here where it's just a loop, right? But you can't necessarily see the loop. What you're looking for is straight out of the vertex, how many lines are leaving. Okay, and that's why I say how my brain does it is that I take like a mini screenshot of that area, and I like don't focus on the rest on the outside. Okay. Is the loop still confusing? A little bit? We'll do another one, okay? So let's say this is going to be a more challenging question. Let's say I have point B and I have a circle, okay? What is the degree of my vertex B? So who says 1? It's not 4. Who has a different answer than 1? Let's do a vote, tribal council style. Okay. Who says 1? Raise your hand. And who says 2? Raise your hand.
Oh crap.
I'm not raising the hand. So the answer is 2, right? Because this here is like a one-way road with a stop sign. Okay? Like this. And I don't know long term if this road is going to loop back and if it's like a circuit. Right? I don't know that. I only care about this part right here. Okay? So here there's 2 lines leaving from B. There's one going up and one going down. You need to learn to ignore the rest of the circle. If it loops back in together, that's one edge, right? That's one line, but the degree goes up by double, right? If you can't remember that, just remember if there's a loop, then there's 2 degrees, okay? If there's a straight line, it's 1 degree per straight line. If there's a loop, it's 2. So here, if you would remember that, you would say in this top one, you would say there's 1 straight line, that's 1 point, 1 straight line, that's 2 points, with a loop, that's 2 points, so 4. Okay? If you want to count like your, like 1, 2, 3, 4. So I'll add that in here. So loop is equal to 2. Edge is equal to 1. Okay? And we're going to do more examples, okay? Yeah? Big boys use big definitions, right? Never forget that. No, I'm talking the WHO, like the WHO, the World Health Organization. Like, it's their job, right? I think that if they wouldn't, like people would be like, I don't know if you're doing your job. Because now it's like reached many countries, which is like the definition of pandemic. But it's like, you know, you have to think of like scientific definitions versus like everyday definitions, you know? You think of pandemic, I'm like, oh my god, everyone's gonna die, like zombie apocalypse, you know? But is that what their definition is? No. You know? Anyways. So we will continue. This time I'm not gonna draw them because, yeah, I won't. The answers are also here, so ignore those. So given the graph below, what is the order of the graph? So what's the definition for the order? So it's 4, yeah. But what's the definition? How did you get 4? So there's 4 points or 4 vertices, right? So if you can count 1, 2, 3, 4, so the order is equal to 4. And like that's the answer, it doesn't get more hard. Okay. Here, right, they told you to say number the vertices, 1, 2, 3, and 4. So there are 4 vertices, the order of the graph is 4. Okay. So here, I'm going to try to hide the answers. So given the graph below, name all of the edges. Okay, so this is our graph. So what's an edge? Yeah, so the edges are the side lengths, right? So we have this one here, which is AB. And it doesn't matter if you write it AB or BA, okay? So if you read from like right to left for some reason, and you write it as BA, that's also okay. And then here you have BC, British Columbia, and BD. So BB is not one because it's not a loop, right? The edge is just a straight line.
So if there's like a loop in a test, then
So if it was written like this, if there was a loop there, then yeah, of course this line is BB.
oh okay, it's gonna be written like that.
Well, there's going to be a loop. Yeah. It's either there's a loop or there's no loop. But you don't have to guess if there's a
You
loop.
could have said that in the beginning.
Well,
I guess.
you could have asked in the beginning. How does that feel? So here what you would say, name all of the edges. You go AB, BC, and BD. Okay? And basically the amount of edges should line up with how many lines you have. So here I have 3 lines, so I have 3 edges. I think it's pretty self-explanatory. Okay? The thing that you can write down on your memory aid, though, is like your definition. Right? So you need to write... Wow. Yes.
Yes.
You know I care deeply about your success, right?
Did you have a memory?
No. So I have to build it.
Let us know. Are you gonna build it with us?
Yes, I'm building it with you. I'm not going to build it by myself.
What the fuck?
I know I have to start from term 1. How does that feel? Okay, so vertices, edges.
Are you
Okay.
recording this?
Yeah. So just in case you get affected, you'll always have my wonderful videos to come back on.
How sweet.
What?
So thoughtful.
Well, if you get affected, I get affected, so there's no videos, right? Chances.
I mean, you're gonna post it.
What?
It's gonna be posted before you die.
I'm not gonna die. Okay, here. So given the graph below, state the degree of each vertex. Okay? So the degree of each vertex is the number of lines that connect, right? This is the intersection of the streets for each point. So how you can do this is A, B, C, D, right? No one does that in their head when they do a math test. They sing their song. Just me. Okay. So what's the degree of point 1 or point A? 1. What's the degree of point B? 3. What's the degree of point C? 2. And of point D? 2. Wow, would you look at that? We're pros. Okay? And where did I get those? Just in case you're not following, right? It's the amount of lines that connect to one of the points. So here, how many lines connect to A? Only 1 line. Here, how many lines connect to B? There's 1, 2, 3 lines. Here in C, there's 1 and 2 lines. In D, there are 1 and 2 lines. Okay? And right, it's going to be written degree of the vertex. So even if you don't remember what it's called, it's like you're going to be like vertex, which is a point, and the degree, so they're asking you a number. So the number of the vertex, right? Okay. Question 4. Given the graph below, name all pairs of adjacent vertices. So this is something I skipped on purpose because I didn't want to confuse you too much at first. So here, right, we don't know what this word adjacent means, okay? Or do we know what the word adjacent means?
Isn't it was like the opposite?
So when we had a triangle, right, not to scare you,
Sorry, I can't see triangle.
or let's draw the triangle here, right? When we had this, and I wanted to find, I had this like angle, right? The adjacent was the one next to it, right? If you say in real life, oh, like the, you know, for example, if you're sitting next to someone, that person is adjacent to me. It just means next to, okay? So here, if 2 vertices are connected by an edge or a line, they're adjacent, right? Because if you are sitting next to your partner right now, then after you're adjacent to them. So here, A is adjacent to B, right? Because A and B are connected. They're next to each other. But A and C are not connected directly, right? So B and C are. So B and C are adjacent. Okay? So here you name all the pairs. So pairs are two, right? You have a pair of socks, pair of shoes, two. So pairs of adjacent vertices. So are A and B adjacent? Yeah? So then you write AB. Are B and C adjacent? Are they connected? Yeah. So you write BC. Are C and D adjacent? Are they connected? Yeah. Are D and B connected? Are A and D connected? No. So I don't write that down. Are A and C connected? No. So it has to be a direct link, right? You wouldn't say someone that's like, you know, at the Kushal is adjacent to you. That makes no sense, right? Adjacent has to be connected or like close to, okay? So when they're connected by a line, that's the adjacent right here, AB. BC, BC, CD, CD, and DB, DB. Okay? So basically, you're naming the edges. Okay? You're naming the sides. How does that make us feel? Bored out of our minds? Yeah. A little bit. It's okay to be honest. Right? But we're learning so much, right? Also, tax season has started, just so that you're aware.
Wait, what happened?
Tax season?
I got my tax.
Yeah? Me too. I was pretty happy with my return. But I don't make that much.
I
Right?
didn't get it.
I mean, this summer, like, the whole year, I made like $4,000.
Yeah, that's pretty good.
I didn't put on my return.
That's the video.
Yeah?
I had one now.
You can put it on your desk.
So wait.
Ooh.
So I think he needs to go brush his comb.
Yeah, definitely. I would.
Why are you so sick?
So drunk.
Good job.
Can I go?
Just take the pass, okay?
Can I go? Do you have this? Can I go my locker and get this?
No.
It's just my dad has curly.
Well, after he comes back.
My dad gets like curly.
Does that sound good after he comes back?
Yeah, why are you touching me?
Okay, but you better come back with disinfectant though. Because if you don't, then after I'm gonna...
Shit.
You don't have to share it. You just have to bring it back for proof.
You want me to bring it back to
Or take a picture, I don't know.
Smell my hands.
No, I don't want to smell your hands. How did that feel? Oh, so you need your phone to go get disinfectant now. Okay, here we get to make a graph. It's like science rules. You get to make something, right? So make a graph with the vertices A, B, C, and D, so they're there, and edges A, B, B, C, and B, D. So you're going to tell me what lines I should draw, okay? So what is edge AB? What should I do for that? Yeah, so I would draw the line from A to B. My next edge is BC, so what would I do? My next edge is BD, so what would I do with that? And look at the final answer. We were correct. Yay.
Yay.
Okay? It's really not more difficult than that. Okay? So here, just in case you zoned out for like 2 seconds, they gave me my vertices, they gave me my edges, I put edges on the plot, on the graph. If this is easy, that means I'm doing a really good job, right?
Yes.
That's what I think. So how does that feel? Good? So we know what a vertex is, we know what an edge is, we know what the degree of a vertex is, and then we know what an order is, right? The order is the number of vertices. So if you know that, then you're pretty good. Okay. Da 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 da. That was lesson 1 done in like 5 minutes. Pretty good, eh?
Oh my god.
Y'all should be really proud of me, you know, like being able to teach this fast. Just kidding. I'm trying to make jokes so that like you like somewhat feel alive and happy today, given all the negative news and stuff. Pros that the school's famous, right? Like that's pretty cool. You said it, not me. So now we're going to continue the graph theory notes, okay? So this was our first part of graph theory. So vertex, edge, order of the graph, degree of vertex, right? I think that this is kind of like pretty basic. You just need to be able to write this down on your memory aid. Okay? So next part. So let me draw out this beautiful graph for you. It involves Ronan's favorite, which are loops. Okay? So here I have a graph. Okay? It kind of looks like an egg, or looks like, well, it doesn't look like an egg, but looks like maybe a leaf in the autumn, right? You can connect it like this, and
Sure.
you know,
Sure.
maybe connecting it to your life somehow. I don't know. Okay? So when you have this type of situation, okay, so you have 2 different vertices and 2 different edges that both connect in the same way, they're called parallel. Okay? So this is an example of parallel. Okay? So edges that join the same 2 vertices. Okay?
Okay, I have a perfect story. Basically, it's in my car. So I went to Miss Carver's. Do you want proof?
Okay?
Yeah, ask.
So edges that join. Oh, sorry. You didn't even. No one even told me that you couldn't see the board. Well, that's what I got from that observation. So edges. So here, if I have something like this, I drew in the leaf, right, just for aesthetic value, but really it's just A and B. There's a point on top. There's a line on top and a line on the bottom, right? So if you have two or more edges that join the same 2 vertices, they're parallel. Are these like parallel, like how you learned in elementary school, like this? No, right? But in this case, right, it's almost like there's 2 lines that connect the same 2 points. So I want you to feel the problem if I had to label these edges. So what would I call the top edge? Like this line here. What would I call that? What would I label it as? What? So here, let me redraw this. Okay, A and B, and I have this. Oh my God, I'm so sorry. And I have this. Okay. What would my top line be? What would I call this line to this point? So I would call it AB, right? But what would I call the bottom one? So it's also AB, right? Does this seem to be a problem? Well, I think from in terms of if I had to tell you, right, if you were here and I say, oh, take road AB, right, you don't know which one I'm talking about. So how we do it when they're parallel is that we do, one of them is AB1, one of them is AB2. And if you had a third parallel option like this, right, it would be AB3. Okay? Just so that you're aware. You give up? Also, I'm only here up to lift today. So if you need to submit anything, you can send it to the office and then they'll put it in my mailbox. So don't feel stressed, okay? And I hope everyone enjoys their pet day tomorrow.
I should call
Any? Yeah. Yeah. I'm not crazy, right? There's a pet day tomorrow.
Yes, there is.
Well, I'm glad you found out. Like now, long weekend, right? I'm gonna go to like Old Port and stuff, walk around. I think it's gonna be a nice weekend. So.
Is it supposed to be sunny tomorrow?
What?
I'll check right now.
Yeah, let me know what the weather is.
You never said anything.
Okay. So now, Ronan, I have a question for you. Did you enjoy the loops? Did you like the loops?
Like the loops here?
Yeah. So the answer is supposed to be no. Okay. If you have a graph
No, I didn't like the loops.
that's like this, right? If you have no loops, okay, it's called simple.
They'd be raining all day tomorrow.
Really?
A lot.
So I'll do my homework instead.
90%. Saturday, 3 degrees.
Okay.
And then Sunday, negative 2.
And here, if I have this example and I have a loop here, this is called not simple. So loops. Sorry. So if you have a graph that's like this, it's simple, it's basic, it's easy. For us, it was really clear. The loops are not simple. Okay? The reason why we're doing simple and not simple with respect to parallel is that there's also this example here, right? That if you have parallel lines here, right, this is also considered not simple. Yeah, so is Coachella.
But no, Coachella got postponed.
Well, postponed. Is the hockey game tonight? The Sharks versus Habs?
Probably.
But it's like empty arena, right? Oh, Buffalo? Really? That makes more sense. Because I was like, why is Florida shutting down?
Florida?
There's a lot of crackheads.
In Florida? I've never been to Florida.
Talking about the NBA.
Really?
Hockey. No, they're gonna have a game, but no one in the stadium.
Why?
It'll only be like.
That's so stupid.
Well, it's propagation of virus, you know.
Yeah, one of the players has the coronavirus, so like.
Really?
Yeah, one player has it, so that's why he can't play.
From who?
Rip.
This was like on the news or some shit like that. Coachella.
You came back with your phone.
I did. Thank you for your gratitude, sir.
So here, simple is no loops, right? And if there's a loop or if there's parallel, they're not simple. What? You okay? You okay? I know this might seem like too easy, and I think it is. What?
No, not you.
Is it something I said? No?
No, nothing you said.
Okay. Okay. So let's say I go back to my my first kind of picture. Well, I'm going to draw a new one. But let's say I have the vertices A, B, C, and D. I didn't sing this time because I knew you guys would make fun of me. Okay? But here, so I have A, B, C, and D. Okay? If I can get through like a maze, right, and I can go and touch every single one of the points, then it's connected. If it's like this, right, this is not connected, okay? Because there's no way for you to get from this part of the graph to this part. There's no like invisible jump where you can jump over the railroad lines or something like that, okay? If you can't touch every point with at least one line, it's not connected. So this here is not connected. And that makes sense, right? If you remember what the word connected means, and they're not touching or they're not connected, then it means it's not connected. Okay? An example of connected, right? I'll fix this for you. So A, B, C, and D. right? If I do something like this is connected. Because all of the vertices on the graph can touch, okay? There's a line that at least connects them all.
I can vote.
Well, you don't get a say.
I'm gonna go home.
Canada government gets a say.
Yeah.
I think Alan's coming back here for one show if we need.
Okay.
What do you mean?
The next thing to do, okay, so we talked about connection. Next, we're going to do about complete. So this here, right? This here is connected, okay? But you can't get from any point to another, right? So if I'm at B, I can't get to D directly, right? They're not adjacent to each other. If I'm from A, I cannot get to D directly, right? So this here is called incomplete. Okay? The other example, right, is where you're probably, I'm alluding to. But if you have A, B, C, and D, and you have this type of X configuration, right, you can get directly from one point to another at all times, right? So this here is complete. So what I would recommend on your crib sheet, right, is that this is what you do. Instead of writing out definitions, which aren't really going to help you, you draw a little picture next to the word. So if they ever say, classify this as incomplete or complete, you look at the picture and you compare these two and you're going to be like, oh yeah, I remember what he was talking about, right? And this is complete because at point A you can go to B, D, and C. But this one here is incomplete because you can't go from A to C and you can't go from A to D. Okay, that's my tip for you. To remember the definitions, like just draw pictures instead. And you can draw little mini pictures, right? It doesn't have to be as big as this. And that was day 2's lesson. Look how fast we're doing this, right?
That was great.
We're just gonna do a couple examples and then we'll see how it goes. I know that this is a lot of like just info dump, so I beg for your forgiveness. Okay. So now I'm going to compare to the notes and I'm going to compare to these things at the same time. So question 1 here. So it says, if you need help reading on a test, I can help you with that too. But the graph below is not simple. Okay? Name an edge that when removed makes the graph simple. Okay? So if we don't remember what simple means, we go back here. Simple says no loops. Okay? So they're asking us, name an edge that when removed makes the graph simple. So what can we remove to make this graph simple? So here we'll go back again, okay?
Wait, I know.
Simple means no loops.
I know.
So what do I remove to get rid of the loop?
You just remove the BC1.
So you can do one or the other, right? If you remove BC1, right, then after this is simple. If you remove BC2, that also works. Okay? That's pretty much it. But if you know what the definition of simple and not simple are, then it's kind of really easy. Okay. This one's even more fun. So the graph below is not connected. Name an edge that when added makes the graph connected. So who would like to name an edge that would make this graph connected? Yes, Ronan. Pardon?
Can I go back to one?
Yeah, so BC would work? So you can connect it from here to here. That would make it connected. What's another answer? Pardon? A to D, yeah. And there's two more answers. So BD and AC. Okay? So you can either connect it this way, you can connect it this way, or this way. Those are all good answers.
Hello.
Okay? And here you only even had to name one.
What? Great.
Okay. This is all here. Question 4. Albert has 4 friends, rest in peace. Bob, Chuck, Dave, and Eric. This is like the most like
Oh
the
my God.
whitest like crew I've ever seen in my life. Like Albert, Bob, Chuck, Dave, and Eric. Anyways, I think it's funny. Dave and Eric each have 3 friends. Dave is friends with Eric, but is not friends with Chuck. Bob is friends with each of Albert's friends. Make a graph that represents the situation and then name Chuck's friends. Bro. Okay.
We just named them.
Oh, it's because I just understand why. Because it's A, B, C, D, E. And all their names start with A, B, C, D, and E. That's smart of them. They're even smarter than me. Okay, so first step here, place 5 points at random, label the vertices. So this is Albert, this is Bob, this is Chuck, this is Dave, and this is Eric. Okay? So Dave and Eric each have 3 friends. So there's not really information that we can do with that, right? Because there's 4 people. So Dave is friends with Eric. So Dave is friends with Eric, but he's not friends with Chuck. Okay? Sorry. But Dave also has 3 friends. So Dave is friends with Eric. Dave is friends with, what's his name, Albert? And then Dave also has to be friends with Bob.
Has to.
Well, because he has 3 friends and he's not friends with Chuck. There's beef in this gang, I guess. Okay. Bob is friends with each of Albert's friends. Okay. That doesn't really help us. Dave and Eric each have 3 friends. So Eric is here. Sorry, my brain is so slow this morning. Well, Bob is friends with each of Albert's friends, right? So Bob has to be friends with Chuck. Bob has to be friends with Dave. Bob has to be friends with Eric, but then is not friends with Albert, I guess, right? Or he is, right? That's what I would say. And then Eric each have 3 friends. I'm very confused as well. I think that there's missing information, eh? Can anyone see the answer?
That's the answer. Wait, what's the answer? Oh, that's the answer. How the fuck?
But here's the thing. Okay, so they are here. Because here it says step 2, join each pair of friends with an edge. But they didn't tell us that.
That's so
Right? So Albert also has 4 friends. So I guess it's like that. Because Dave and Chuck aren't friends.
yeah, that's how it is.
So that's what it is.
That is stupid. I hate it.
That was pretty... My questions will not be this intolerable.
Hope not. I will reply to this.
I don't want to do this. It's 8:54. It's 8 what?
50.
It's 8:50?
Have a long time.
Yeah, well, I have my real time. What is 8:50? My laptop's off. Okay, I think that's where we're going to end today. it's not worth keep going on. We're gonna do paths and circuits next class.
Okay.
Okay. So we can stop the recording.